my name is Zorig, and my student ID is 14535684. I'll walk you through the implementation process of our cloud-based insurance client management system. As you can see on the screen, our platform has been designed with strong security controls and resilient architecture. Therefore, I will explain the key AWS components we have configured, explain why these settings are important, and show how they integrate together to form the core of our secure workflow. First, I have begun with AWS Key Management Service. Here as displayed in the console, I have created a customer managed key named Insurance KMC. This symmetric key has been the foundation of our platform's encryption. Notice that I have chosen encrypt and decrypt. So the same key has been consistently applied across DynamoDB, S3 Packet, and Lambda. By managing the key ourselves, our platform has maintained control over administrators, key rotation, and audit logging. This ensures that sensitive claim data has always remained encrypted under our control. Now, as you can see here, I have set up the Amazon S3 packet that our platform uses to store claim documents. I have enabled log public access to prevent exposure, and under the Properties tab, versioning has been turned on so that accidental deletions or overwrites can be rolled back. As displayed in the encryption settings, I have applied our KMC key so every document is encrypted automatically. In the Permissions tab, I have added TLS-only packet policy to deny insecure connections. These settings have ensured that our platform's client documents are always confidential, encrypted, and recoverable. Next, DynamoDB table. For claim records, I created DynamoDB table called claims with claim ID as partition key. As displayed, I have selected on-demand capacity mode, so our platform can scale automatically with usage. Encryption at rest has been enabled with our KMC key, and under the Backups tab, point in recovery has been turned on. This feature has allowed our system to restore the database to any second in last 35 days, which has been vital for our audits, compliance, and disaster recovery. Next, there are IAM policy and Lambda role. As shown, I have created custom IAM policy that grants access only to S3 packet, the DynamoDB claims label, and KMC key, nothing else. After saving the policy, you can see it attached here to the claims Lambda role, alongside the AWS Lambda basic execution role. This design has imposed least privilege, which means that in our platform, each Lambda has only the permissions it requires, and all activity has been logged for compliance. Next, the Lambda functions. Here, as you can see in the Lambda console, I have created two functions that form the logic of our platform. Create claim has validated data and stored in DynamoDB. Pre-sign upload has generated pre-signed S3 URL. Wait a minute. Includes server-side encryption AWS KMC, which has imparted encryption on uploaded documents. Both functions have used the secure execution rule I created, so they have been strictly limited to the claims table, the packet, and the KMC key. At the last, API gateway. Next, as displayed in the API gateway console, I have created HTTP API that connects customer to our platform. You can see that route post claims has been integrated with create claim function, and post claims pre-sign has been connected to pre-sign upload function. The API has been configured with HTTPS only, and throttling has been applied to manage request volumes. By putting API gateway in front of the lambdas, our platform has ensured that all requests are validated and securely routed through single controlled entry point. Now let's bring it all together. As you can see in the architecture view of our system, a customer has submitted climb request through API gateway. The request is distributed with create climb lambda, which has written securely into DynamoDB using our KMC key. If documents have needed to be uploaded, the pre-sign upload lambda has generated a secret URL. That URL has allowed the customer to upload directly into our encrypted S3 packet, where versioning and TLS-only policies has been enforced. At every step, IAM and KMC have granted that only authorized encrypted operations have occurred on our platform. In summary, as you have seen throughout this demonstration, each service has played a critical role in our security infrastructure. KMC has enforced encryption, S3 and DynamoDB has secured the data, IAM has enforced least privilege, Lambda has implemented the business logic, and API Gateway has securely exposed the workflow to clients. Together they have formed a serverless, integrated system that has kept our platform's insurance claim data safe, compliant, and reliable. Thank you for your attention. Now I'll hand over to my teammate, Rudaba.
Hi, my name is Rudaba and my student ID is 25220 Today I'm going to present our cloud security project on cloud-based insurance claim management system. The focus of my work was mainly on the security section of this project where I created the CloudFront, CloudTrail, Security Hub and Guard Duty. So now I'm going to explain step by step what I did and how I did it. So at first I will go with the CloudTrail one. And for that, if we search for the CloudTrail here, we will see that we have a trail name, this, and if we go inside of this trail, we will see that it is a multi-regional trail and the trail name as well. And if we go that inside of this one, we can see that all the management events and data events are recorded in this trail using our existing S3 bucket, which is named claim trail. Now, if we want to check if our CloudTrail is working just fine, we will use the Cloud Shell and run some command to check it. So this command over here actually returns a table which shows us that the trail is active and it is storing the logs correctly. To check if it is giving us the right timestamps, we will run another command in the Cloud Shell. So it is giving a true output and also it is giving us all the timestamps including the latest delivery time, the start logging time, also the time logging started. And this time logging started actually explains when we created our system, which is on September 14th when we did our report. So this is how we know that our CloudTrail is actually active in the system. It is very important to active the CloudTrail system because it is important for the forensic investigation, compliance, and auditability. Now, if we go back and then I will explain the guard duty. So I have enabled the guard duty, Amazon guard duty, and it is continuously monitoring the CloudTrail logs, VVC log, flow logs, and the DNS logs for any suspicious activity happening in the system. So after enabling it, I have generated some sample findings to demonstrate the detection, and we will find in the finding under the finding tab. If we go in here, it already shows that we have some findings. If we go view all findings, we will see all the findings of this cloud trail that has been detected. So if we go, for example, we have this one, which is a low severity, which is the root use, which explains that the root user is invoking APIs using in discovery tactics. And this is a high severity one, and this one is also a high severity one, which is a reverse fail was detected in EC2 instance. So this detection as are visible in Guard Duty Console under the Findings tab, as I showed before. And each of these includes the finding types, resources, counts, account ID, and last seen as well. It's raised a month ago because we created our system a month ago during our report. This kind of continuous threat detection is very important for the system because it actually gives the visibility into potential compromise events, and it helps us not to require manually inspect the logs, which saves time, and it is also very efficient. So the next major part was configuring the Amazon CloudFront for our Claims API integrated with the web application firewall. So I'll go for show that now. So I have created a new CloudFront distribution, which is this one. And if we go inside of this one, we can see that I have set the API gateway endpoint as the origin, and behaviors were set to use HTTP only. And for the web application firewall, I have enabled the managed core rule set. I have enabled the injection protection, and I have also configured a rate-based rule to limit repeated request for from a single IP. This means all the traffic must enter through CloudFront. Suspicious traffic is filtered at the edge before it ever reaches the API gateway or Lambda, improving both security and cost efficiency. So if we want to check if our CloudFront is working just fine, we have to just first enable the Claim API's IC prod. So if we go to the API gateway, select Claim API and go to Stages, then we select the IC prod, and if we deploy it, like deploy means we are just manually enabling this one. So now if we go to the CloudFront and then then a new Cloud Shell. So now if you want to check that our web application firewall is actually giving some protection to our system, we will try to run some commands. So this one. So this one actually returned a 201, which means that a valid traffic flows through correctly, and we can see that everything in the content and everything is fine because it is not a malicious command or malicious content. But now if we try to inject a SQL simulation, let's see what happens. So if we try to do a SQL injection in the system, it actually gives a 403. It returns a 403, which means it is actually blocking that, and the malicious payloads were intercepted at the edge because of the web application firewall we created in here. So this demonstrates how our CloudFront and web application firewall are acting as a web security perimeter, providing a network layer for DDoS protection, and also application layer is filtering in a serverless way. This was the main target for our CloudFront. Final thing I enabled was the security hub. to get a single unified unified view of security posture across services. After onboarding, I integrated the guard duty findings into Security Hub. As I shown before, that there is a findings of the low severity or high severity issues. And in the Security Hub dashboard, we could see that the threat summaries, they list the low severity root API misuse, and exposure summary showing zero critical issues as well. Security Hub continuously checks compliances against AWS best practices and also CIS benchmarks, uh, and findings from Guard Duty, CloudTrail, and other services as well in this system. So it gives basically a centralized visibility and helps us to prioritize remediation, like which one should we do first, the lower ones, the higher ones. We can see that. So in here we can just see that we have only 3 low severity issues, which we can ignore if we have like more important things. If we had critical or high risk issues, then we should have focused on these ones first, and then we can check these ones as well. So as our future work, we have a plan to implement the Amazon Cognito for our system to user authentication and authorization, because it can manage the sign up and or sign in for policyholders, and while API gateway can use the Cognito authorizers to protect API routes, and it will strengthen our identity security without custom authorization code or anything. Thank you.